Hi friends, in this video we can see a few problems in the first unit of 10th CBSE Maths real numbers. First we can see example 1 where we are asked to calculate the HCF of two numbers. For this we will be using a lemma which states given a positive integer a and b, given positive integers a and b, there exist unique integers q and r satisfying a condition a is equal to bq plus r, where r lies between 0 and b. So this is the condition and this is the lemma. Using this lemma, we are going to calculate HCF of two numbers. Okay, for this, let us move on to the problem example 1. Here, example 1 is given and it is being asked to calculate HCF between of 4052 and 12576. So let's have a rough work for our convenience. So here for calculating HCF, the larger number is to be taken as A and the smaller one is to be considered as B. So using these two numbers, we have to substitute them in the lemma, that is 12576 is equal to 4052 into q plus r. Here q and r are to be calculated. For our convenience, this is the quotient and this is the remainder. We can consider it as quotient and remainder. So what is the quotient? That is, we have to divide 12576 by 4052. That is a larger number by smaller number, A by B. So this is the A and this is B, A by B. So approximately it comes to 3 times. That is, when we are calculating 4052 into 3 will be 6, 15, carry 1, so 1, 12. So 1, 2, 1, 5, 6. So 0, 2, 4, 420. So this is Q and this is supposed to be R. So we can substitute this value here. 12576 is equal to 4052 into what is Q is 3 and R is 420. Again, we have to consider the larger one of RHS. Larger one of RHS as A and smaller one as B, and repeat the same procedure. So in the second step, A is nothing but 4052 and B is nothing but 420 into how many times plus what? So again we are going to divide this 4052 by 420. So it comes approximately 9 times. So 420 into 9 is 0, 18, 1, 36 and 37. So 3780. So here 2. Here you will be arriving at 7 and here it will be 3 and 9. 10. So here you will get 2. Because you have given the carry here, so you will have this. So 272. So what is to be filled here is 9 and 272. Again you have to repeat this. This is our A and this is our B. Again we have to repeat the same. So 420 is equal to 272 into how many times plus what? So how many times? Looking into the problem here, it is meant to be one time. One time and remainder is 148. One time and 148. So again the same thing. Here 272 is equal to 148 into how many times? Almost one time. And the remainder is 124. 272 and 148. So again 148 is equal to 124 into how many times? Approximately one time plus what? 24. Again we have to repeat this. 124 is equal to 24 into what? How many times? It is 5 times to arrive at 120 and the remainder will be 4. So here again 24 is equal to what? 4 here. So 4 into how many times will be 24? 6 times. And the remainder will be 0. This procedure we have to repeat till the remainder becomes 0. Okay? If the remainder becomes 0, then the quotient Q is our HCF. Okay? So the procedure here in the book, it's given like this. So first this is our A and this is our B. Again we are repeating the procedure by taking the RHS and considering A to be the larger number and B to be the next larger number. The smaller number. Again and again. So till this point, the remainder till it becomes 0, the procedure has to be repeated, and this is our quotient, and finally the HCF between the two numbers is 4. That is our final answer. So this is problem 1. Then we can move on to problem 2. Here in problem 2, it's nothing but it is a problem that we have to prove. So what it states that, show that every positive even integer is of the form 2q. Every positive even integer is of the form 2q, and every every positive odd integer is of the form 2q plus 1. So this we have to prove. For this, let us just assume some integer q is equal to, for example, 2. Some integer q is equal to 1. Okay. For this assumption, if we are substituting it in 2q, 2 into 1 is equal to 2. This is our first case. Okay. Then 2q plus 1 is equal to 2 into 1 plus 1. That is 3. This is our case 1. So this is an even integer, that is for 2q, and this is an odd integer, that is for 2q plus 1. Let us assume randomly another number. That is, for example, let us assume q to be 10. Then 2q is equal to 2 into 10 will again be an even integer, and 2q plus 1 will again be 2 into 10 plus 1, that is 21, and this is again odd. This you can prove it like this also, but what they have used is, let us have any positive integer and b is equal to 2. They have assumed b is equal to 2. Okay, by applying this algorithm for the positive integer, a is equal to 2q plus r. So whenever q is, this we know, q will be greater than 0 or equal to 0. So for r is equal to 0 and r is equal to 1 condition they have checked. So for r is equal to 0, a will be 2q. When r is equal to 1, q will be 2q plus 1. So if we are considering b to be 2, r can be between 0 and 1, that's all. R can have values 0 and 1, only two values, because r should be less than 2. So these two values is applicable for r. So when we are applying this r here, we will be having 2q here. When r is 1, then this is 2q plus 1. So when the remainder is 1, it is an odd integer. When the remainder falls in 1, that is a is equal to 2q plus r. This we know. Here b value is 2. So r can have two values. R can have two values, that is 0 and 1. When r is equal to 0, a will be 2q. When r is equal to 1, a will be 2q plus 1. So when we are having a remainder as 1, we will be getting an odd value 2q plus 1, and when remainder is 0, we will be getting an even value 2q. So it can have two values, that is 2q and 2q plus 1. That is the proof. This is for problem 2. The problem 3 is of similar fashion, where they have given, that is any positive odd integer, they have mentioned it to be odd, is of the form 4q plus 1 or 4q plus 3. Any odd number will be in 1, 3, 5 fashions. So any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Same thing we are going to apply. Here we are going to take b as 4, value of b as 4, and when we are going to apply it in the form, r can have these values. So 3 values, r will be less than 4. So 0, 1, 2 and 3. So we can have the values, possible values as 4q, 4q plus 1, 4q plus 2 and 4q plus 3. Okay, all these values are possible. But however, since a is odd, a has to be odd. So in that condition, if a is odd, that is a can have conditions. A is equal to, for 3, a is equal to 4q plus 1, 4q plus 2, 4q plus 3. It can have all these conditions. So if a has to be odd, it is a product of 4. So for any value of q being substituted, for example q is equal to 1, a is equal to 4q, that is 4. Q is equal to 2, a is equal to 4q, that is 8. This will give even numbers. So this will give you an even number, and similarly this will give you an even number. So the possibility for odd numbers are these two. So as it has been mentioned as odd number, we can have the choices of these two only, plus 1 and plus 3. So this can be proved. However, since A is odd, A cannot be 4Q and 4Q plus 2, since they both are divisible by 2. Therefore, an odd integer is of form 4Q plus 1 and 4Q plus 3. This has been proved hence. Okay. So as of now, we have seen 3 example problems in the real numbers, the first chapter of 10th Maths CBSE. Thank you all for listening to these problems in this video. Keep watching. Thank you.